Okay. Okay. This is take 2. Take 1 got interrupted by a lizard. A lizard, you might ask. It's yeah, my cats caught in a lizard yesterday. Like quite big. I mean, enough to scare the shit out of me. I mean, to be fair, it doesn't take a lot. Like, well, snakes and lizards scared. Quite scary for me. And of course, they bring both of them inside quite often. My chair's sinking. Okay. Now that that's out of the way and not distracted by the lizard for now. Yeah. Okay, so yesterday I got as far as this. That. Don't know if it's visible, but like I'm right into the display. I mean, it's supposed to be the whole display, but only about 4 lines show up. No idea where the rest of it is going. Yeah, so that's where I'm at. I mean, I'm obviously missing something. Yeah, so oh my god. So what I'm thinking is, well, go back to the data sheet, see if I missed something. So where I think the bit about writing to page. Damn. Gotta stop saying damn. I never use damn that much. Okay. 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 Reset circuit. Segment drivers, no. Yes. Graphic display data. Wonder if there's a way to debug this. Because right now, well, there are no errors because the LED is off. So it's writing, but somehow writing only 4 lines. It's got a lot more lines. It's writing like individual pixels, like just 4 lines of them. Strange. It's my okay, I'm just gonna read through this. So the RAM is a bitmapped static RAM holding the bit pattern to be displayed. The size of the RAM is monochrome 128/64. times 64. When 1 data byte is written to the RAM, all the rows image data of the same page of the current column are filled. When 1 byte is written, all the rows image data of the same page. Of the current column are filled, i.e., that is, the whole column pointed by the column address pointer is filled. When 1 data byte is written into RAM, all the rows image data of the same page of the current column. Damn, that is quite confusing. All the rows image data of the same page. All the rows image data of the same page of the current column are filled. That is, the whole column pointed by the column address pointer. Column address now this is page address 0 to 3. Each box represents 1 bit of image data. Segment 0 so it's column wise. So when I write, it's writing this way. I mean, it should be fine, really. It should still be all 1. Hang on. Control data. Send control data. What if I send one zero, like make this 80? What am I doing? So I excuse me. I initialize the display. This works if the display turns on. set the addressing mode. It's the wrap one, like the line wrap, auto line wrap. Right. And so yeah, it's control command, the addressing mode, and some data for what addressing mode it is. The column address. I wonder. Yeah, let me check that bit. Notification. Where was it? Set page address. Is this it? Not sure. No, I think I've gone too far. Horizontal addressing mode. Set memory address. Addressing setting table. I wonder in between setting memory addressing and column address, if there needs to be another control command, because I'm sending spider. Because I'm sending 3 bytes, or 4, 5, 6 bytes. Is there an explanation? Power on. Reset. Okay, kind of lost. Set memory addressing. Command descriptors. This command specifies the lower nibble of the 8-bit column start address for the display data under page addressing mode. The column address will be incremented by each data access. Please refer to 9.1. I think that's the table. Set higher column start address for page addressing mode. Set lower column start. Not sure. Set memory addressing mode. There are 3 different memory addressing mode in the SSD 1306. Page addressing, horizontal, vertical. So I've picked the horizontal addressing. In horizontal addressing mode, after the display RAM is written, red/written, the column address pointer will be increased automatically by 1. If the column address pointer reaches the column end address, the column address pointer is reset to column start address and page address. Okay, yeah, I know that bit. Sequence of movement of the page and column. Yeah, this way. Okay. Set column address. This triple byte command specifies column start address and end address of the display data RAM. This also sets the column address pointer to column start address. I wonder if my start address is wrong, because it's starting at the middle of the page at the moment. If excuse me, if horizontal address increment mode is enabled by command 20h, I think I have, yeah. After finishing read write one column data, it is incremented automatically to the next column address. Yeah, one column data. Yeah, whenever the column address pointer finishes accessing the end column address, it is reset back to the start column address and the row address is incremented to the next row. Okay. Set page address. This triple byte command, I don't know, it's triple byte command, so I guess there needs to be a control command here. I don't know. Just wanna double check. No, that does literally nothing. So that's not necessary. You know, it wouldn't bother me, so I thought I'll check it out. Specifies page start address and end address for the display data. This command also sets the page address pointer to page start address. I feel like it's a bit too loud. That's better. Yeah, it's better. It's incremented automatically to the next page address. Whenever the page address pointer finishes accessing the page address, it is reset back to the start page address. Right. This diagram is a bit confusing. Starts at 1, goes to 6, and then comes back to 1. Okay, it's just, guessing it's just representational. Start address is set to 2 and column address is set to 125. Page start address is set to 1 and the page end address is set to 6. Oh my god, I am so stuck. Set display start line. Actually, don't set the display start line. Determine starting address of the display RAM by selecting a value from 0 to 63 with value 0 equals 0. RAM row is mapped to column 0. Whoa. This kinda seems important. Refer to table. Damn, why this table? It's a scary ass table. So if you don't remap, this is what it's set to. Start line 40H to 7F. 40 to 7. What about the rest? Why 40? Where's the command table? So I gotta check set display start line. Here. Set display start line. From 0 to 63 using the last 5 bits. Okay, so it is set to 0 during reset. And I think during initialization. Let me just double check. Where's the initialization? Yeah, it's I think it's all the way to the bottom. Yeah. Oh. Actually, I don't reset the display. Maybe I should. reset this display. Maybe in the command table. Reset circuit. Command table, not this one. Yeah, oh, close enough. So how do I reset display? Command table. Here. A4. I do send A4. But I don't think it's part of the initialization. Disable entire display on. Here. What is it? Yeah, here. Fuck. This to reset. Display off. Assumes to RAM content display. Or I can just set the start to 0. Set page address. Don't I set this page address? Yeah, I do. Totally forgot what I was doing. Display offset. What's this? It? Or was this it? Display start line register is reset to 0 during reset. Can I set it? So it's 40 to 7. Set display start line. I reckon I can just do a reset. Let's try both. So I'm gonna try A4. Display reset. Excuse me. Okay. Display on. So reset A4. So after I set the column address, yeah, let's try. So I'm gonna copy this, paste, reset, command. Don't need this, reset. Then right, reset. Right. I really doubt that's gonna work. Damn. Oh, yeah, sorry. I was like, the display's off. Oh, it's off. Don't think that did anything. Maybe I do it before I set the column address. Can't hurt. So disconnect. Right. And copy it over. No, still the same. What am I? Oh, maybe I try the other reset. So my other option is to use this command to set it to 0. Set display RAM display start line register from 0 to 63. I want to set this to 0. So do I pass a value after this command? This is a range. Was it after? I think so. Here. Set display start line. This command sets the display start line register to determine starting address of the display RAM by selecting a value from 0 to 63. So what does this mean? Hang on. Maybe let me check the table again. So x2, yeah, I want hexadecimal to decimal. What are the values? 40 to 7. That's 64. And what is 7? 128. So I said the first one, and the rest is 0. Not sure about this one. Row 0, RAM 0. Oh, this is A. Oh, yeah, this is what I want. Right now I'm getting... What is C? What do these numbers mean? 664. Okay, let me check. Andrew. What's it called? Actually, there's another blog. Yeah, here. And let's see how he sets display offset. Let's scan. Hang on, what is this? This is a double byte command. The second command specifies the mapping of the display start line to one of this. Assuming that column C, oh no, it's not column, it's com. This is the pin. Is the display start line of the register is equal to 0. For example, to move COM16 towards COM0 direction by 16 lines, the 6-bit data in the second byte should be given as no clue. I'll come back to this one. Excuse me. What did I want to check? Yeah, this one. Display start line. Display start. Yeah, don't even mention it. If I even here, display start. Command set page address. Send command. That is send command. Mode write. Write control command. Write command. Yeah. And then where did it go? Sending RAM data. Control data. But in this case, we want to allow sending a byte buffer that contains the display data. Is it because control data, where is that defined? He only sends one, then he writes the buffer. Okay. You can, I'll just remove this, no need. Reset. Then where do I write? So data, so device dot write, then write the buffer. So you gotta write it once. Okay. I mean, it's pretty ugly, but I'm just gonna want to make it work first. So what I'm gonna do is I'm just gonna write control data. That what is it? What does it expect? Oh, it expects a slice. Yeah, this one. Can I just do it here? Then just get rid of this and this. Is that valid syntax? Looks like it. Then here, I want to see his device dot write. Just writes send stop condition. To be fair, I don't do any of this. What is the stop condition? No idea. Ignoring that for now. Just gonna write one byte. Okay. Yeah. Oh, sorry. That one is because it expects a slice. And same here. Okay. It goes nothing. Oh, damn. There's nothing there now. Not even the 4 lines. I want to check something. Okay. Oof. Okay. That's worse than before. Undo. No, I think I'm genuinely stuck now. See what Andrew does. That's not very reassuring. Uh, Solitary failure. Oh. Can I just... Yeah. Do I... And then... No, thank you. Solitary failure. Okay, maybe... Hmm. missing quite a few things when I compare it to this block here, because I don't read. That shouldn't matter, not reading the acknowledgement. Excuse me. 21, 22. Yep. Clear. I do think I cleared the display here. Page buffer. Set addressing mode. I do that. What's the addressing mode? 20. Yeah. Yeah. Do I set it to 0? Shouldn't matter. 0 is 0 either ways, right? Yeah. Then draw. Clear. Control column address, page address. Column address is 21. Yeah. Page address is 22. I'll try 7. Then maybe I'll just double this. 1 0 2 4. Yeah. This here. Yeah. Yeah. Gonna try. It's still the same. Yeah, that is strange. Um, what if, yeah, change that back to 3. $128 per line. The what if I wrote, okay, wrote instead of 512, just did 128. No, 256. 8. So that should only write to 2 lines. Yeah, that does only write to 2 lines. I'm missing something. Each line has, and it doesn't change if I double it, because probably it's just overwriting the existing lines. Damn. All sorts of noise coming out. Yeah, I am quite stuck. Only 4 lines of data. Let me go back to what am I doing wrong? Let me check the page. What does the page look like? Columns 0 to 7 is page 0. Means each page has 7 columns. I've only got 4 pages. What if when I write data, I write this twice? What happens then? Oh, sorry. Yep. Make it underscore. Still the same. Hang on. I just realized something. Bye. Control data. Control data. It's 40. It keeps sinking. That was loud. Why? Why are you not working? It's like, how did you get from there to here? To be fair, even that doesn't work for me. It's got a lot more lines in there. Let me check the cables. Raspberry Pi. Raspberry Pico pin diagram. First one is data. Pin number 1. And the second one is the clock. Yep. What do I do? What do I do? Each byte of data you send to the display will populate 8 rows of the page of the current column. Rows? Thought it was column. Okay, this is a page. For drawing to the display, you have to be able to control where the data is drawn. It's done by setting the column start and end address. So that's the page start and end address. Yeah. Zero and is 7, right? Yes, and end is 1. Yeah, that would be the easiest way. Set everything to 1. But page buffer memset, yeah, set everything to fuck is ff. Fuck, I know why. Oh my god, I can't believe I've just done this. Of course this doesn't work, because oh my god. Okay, I think that's it. I mean, sometimes I just make the silliest mistakes. Okay. I mean, seems like half my display is fucked, but we have written to the display. I don't know if you can see that. I mean, I think half my display doesn't work, but who cares? I am so proud of that. And to think, I'm gonna get another one of these. Yeah, I will. But yeah, fuck. Can't believe that was the reason it wasn't working. Jeez, now that I think of it, it was so stupid. Fuck. Was uh damn. So I was setting it to that's why Andrew couldn't get it to work either. I think he made the same mistake. If I look at his code, oh no, he prints the buffer. That's kind of funny. It's like I spent an hour because I was sending wrong input. Okay. I'm gonna end on that high note. That's pretty cool. Yeah, maybe let me try something. What if send, let's try another number, right? Let's try 12. Just curious what the output looks like. Yeah. I get 1, 2, 3, 4, 5, 6, 7, 8 lines. Nice. Okay. Oof. Reset. Made the silliest mistake ever, but we have written to the entire display. Okay. I think what I would like to do next is what I really want is text and another display, and probably order one after. And yeah, so I think tomorrow I'm gonna try and figure out how to get text on the screen, because that's what I really want. And I think, or yeah, I mean, okay, I might do that as well, but I think text should be okay now that I know. If I can write all ones, I can write text. Famous last words. Right, okay, yeah. I'm gonna do that. Write text tomorrow, and then maybe move on to the Wi-Fi adapter. Welcome to programming. All right, I think that's it. Have a good weekend, and I'll see you tomorrow.